There we go. All right. I'm going to talk about the distribution planning process, and I'll explain in a minute what that is. Go ahead and hit the next slide, please. All right. So this is the electric system, the overview, and you kind of had this already. But I think the important points are to see that bulk generation over on the left, and then you wind up with the transmission as part of the transmission planning process. Then you move into distribution, which is lower voltages. You wind up at distribution stations. Then you wind up with the customer. And that's part of the service planning process when customers come and they need new services. And I do want to discuss at the bottom, the customer panel is not part of the utilities system, because when people talk about panel upgrades, that's really on the customers, individual customers. So go ahead and hit the next slide, please. All right. So this is just a little bit of an overview about who is thank you. Who's the adult in the room for each one of these processes? And just remember that when we're planning and when we're looking at the electric system, we're talking about the peak, because that's when everything needs to be ready. And we're talking about utilization has gone down, but spreading the load, that's going to be a big part of all of our futures. So in terms of generation, which is also called resource adequacy, it's been deregulated in California since 2000. You can have utility, non-utility ownership. We have CCAs, right? Where the cities and counties are purchasing power for customers. So that's the generation piece. And those are the adults in the room to make sure there's enough generation. Then you've got the transmission, which is Cal ISO. But you've also got the balancing authority of Northern California for some of the municipalities. So that's another entity there. And then we're now into where I live, which is the distribution stuff. So it's under CPUC jurisdiction. And the upgrade costs for capacity are typically wind up embedded in rates, as we were talking about, which is why we don't want to overbuild, build in the wrong place, build at the wrong time, keep those rates down. Service facilities, which is where the distribution planning process ends, is the local, basically the customer secondary, the line transformer, either on the ground, pad mounted up on the pole, that service drop to the customer, right? So the cost on that is mostly for residential, on the residential customer. There is allowance, it's under Rule 16, but just to understand that a lot of those costs do fall on the individual customers for upgrades. Facilities beyond the delivery point is the last piece, right? Is the customer panel, and any upgrade on that is 100% customer, because that's customer equipment. All right, so next slide, please. So how do we plan for future loads? So this is kind of like a three-legged stool that we've got here. And on the left is that California Energy Commission, the IPER that we talked about, that integrated energy policy report. Now it's energy, it talks about all kinds of energy. It talks about natural gas, it talks about transportation fuels. It's a great report, highly contested, long drawn out process, but really highly respected because it brings everybody in the room and they all talk about it. In the middle is the piece that the left, so the IPER basically kind of gives us growth for the next 13 years in the state or in the local PG&E system or in the Southern California Edison system. So that's what the IPER is giving us, is kind of what it thinks growth will be, inching up over time. That's used in our forecasts. We take that system level IPER and disaggregate it out to feeders based on where we understand that growth will be occurring. So a little more on that next. But we also have service planning applications. So the middle box is the piece that is customer driven. Customers give us the application for service. It might be one home. It might be a 30,000 home subdivision. It might be a 20 megawatt data center. It's all different. Do we have capacity for it? Depends. What does the load look like? How big is the load? Where is it going? So there's a lot of information in there. Huge difference in the impacts, of course, between one home and 30,000 homes. Big difference, but they all come through the same process. All right. And then on the right, We have our long-term local forecasts that are informed by things that you see or that our account reps see or that information we're getting that tells us where the growth is going to be. Codes, things like that. And this is where we're going to need help from you, is that long-term view. Where are you getting those CEQAs or those EIRs, those the environmental impact assessments for really big new greenfield development? We need to know about that. We need to try and get in on those CEQAs and EIRs for our facilities. And I'll explain a little bit more in a second on that. So this creates our complete forecast. And then the distribution forecasts, of course, inform transmission forecasts because we know where the load is going and transmission needs to know that too. So the question that's been asked a lot is there capacity now? Depends where, what the load is, when is the peak of the load, when is the peak of the local area? Will we have capacity in future for new loads? That's what we have to do. That's our lifeblood. That is the obligation to serve that we have. But it helps if we know where it's going, and it helps if we know what it is. And what does it hourly load profile look like for that new customer or that new subdivision? Is it all electric? All right, next slide, please. So this is kind of how we think through the mitigation options for when we get new applications, when we're planning for those new loads. So the first thing we do, in order of easiest to hardest, is we use existing capacity. Maybe 2 miles away we have capacity, we don't have capacity. Here we will move load around. So that's transfers. Then there's small upgrades we can do, replace wires. New capacity is the third one on the list, and that sometimes involves new substations, new transformers at existing substations. Material lead times have really become an issue. We'll go into that a little bit. And the last one is the DERs, so distributed energy resources, and sort of the flexibility, that moving load around that we're talking about, moving the time of the load. And what's interesting about that is you would think we were all tapped out with as much PV as we can handle. And it depends where it is. So if you've got, your residential areas, peak is at 7 p.m. PV is maxed out, peak is way off in the evening. But your commercial industrial areas are still peaking around 2 p.m. So, downtown Oakland, downtown San Francisco, downtown San Jose, Tejon Pass, which is way industrial. We've got room to move there. We have room for PV to shift that peak, to nibble it down. And I'm not seeing it yet. I'm hoping it's going to happen. Sometimes there's not a lot of room for PV. But it'd be exciting if we could get some of that commercial industrial, more PV. All right. So the guiding principles are on the right-hand side. I'll let you guys read that because you all got the presentation. Next slide, please. All right, so this is the part that really describes where frustration is happening for customers, and it's the capacity upgrade timeline. The new transmission interconnection for really big customers is 3 to 5 years. The new substation is 5 to 8 years. Right now, we have one in San Luis Obispo. It's been taking about 10 to 13 years, and it's the permitting for it, which is why I'm very interested in if you got customers that are coming to you, developers coming to you, and they're going to do a CEQA or an EIR that will need a new substation. We need to be the impacts of the PG&E system, that new substation, the environmental impacts for that need to be on that CEQA. So that's part of GO 131D. And I can't say this enough, is like sometimes we get customers come to us, 20 megawatts, I need 20 megawatts. And I submitted my EIR 3 years ago. Well, what did your EIR say about the power? Where is it going to come from? Oh, it'll come from the utility. No, we need to, this is a partnership. And it's a legal requirement that you have the impacts of the utility system in that CEQA. So we need to back up and make sure we're there. If it's a customer that needs a ton of energy, 30,000 home subdivision, let's find out about it before they apply for service. Let's find out about it now when they're filing the EIR or CEQA. So that's really important part of it. Added substation capacity is shorter, 3 to 4 years is a time frame, and material now is the real driver on that one. It's taking a long time to get big transformers. New circuit 2 to 3 years, circuit line work 2 to 3 years, and the line extension work, that service facility upgrade, is 6 to 12 months. So, all right. Next slide, please. All right. So this is where we're talking about our improvements and where we want to engage. And the number one for me is the CEQA, is really getting in on there if you've got big customers coming in, because it's been missed a lot all over the state. So we want to engage with cities and counties to obtain the multi-year plans, to put that into the planning process, to say, yes, here is where this is happening. But we also need to know what's the magnitude of the load? What is the hourly profile of that load? Like we were saying before, if we've got areas with large air conditioning, a heater in the winter is going to be about the same size. Electric heating is about the same size as air conditioning. So maybe not panel upgrades, maybe not secondary upgrades, maybe not primary upgrades. It's all sized for that summer air conditioning load. But then you've got that near coastal area. In the coastal area, no air conditioning. Put the heat pump in, it's like you've added an air conditioner. What do we have to do upstream? Well, it kind of depends. What does the load look like for everybody else out there already? So that's where we need to team up. We'll continue to use the IPER. The IPER will continue to change and over time include more of the codes and standards. So we need, I think, also to be able to use that load shifting and to put it into the process with how would real-time rates change things? How would more control systems change things? What makes someone adopt control systems or not? Those choices. So that's more increased modeling, because we don't want to say, hey, look, we can reduce all this if we shifted load, if you can't get people to do it, if you can't get people to shift load. So what incentivizes that? So we talked a little bit about the web portal, the ICA, that there's a place where you can look for existing capacity. And there will be improvements to that as we go forward. And we're going to, 5 minutes. I think I'm good. So I'll go into the reliability slides just in case people want to see them. They're part of the appendix, but all right, next slide, please. All right, just wanted to hit on outages and interruptions because I know reliability is sort of a big question for folks. So this was, I'll hit it anyway. So outages and interruptions, weather, vegetation, animals, equipment failure, vehicle accidents. So those cause the outages. PSPS is, of course, planned shut off, and then the EPSS, the Enhanced Powerline Safety Settings, which are now many of the devices out there are on a hair trigger. So when wire goes down, they're like off. They make these worse because in previous years, you want the outage reduced to the smallest area possible. But now you want it picked up by this fast device, because if the wire goes down, you want it off immediately. Don't start a fire. And that means that it's going back further up to the source and it impacts more people. And that will continue to be for public safety. And it will only really get mitigated as we do the undergrounding, as wires get underground. So, next slide, please. So some of how we find out about outages, smart meter data, customer calls, information from automated system. We track the outages and we collect the data and their various metrics about it. And truthfully, the metrics have not been good. Reliability had tremendous metrics before, but because safety is now, you don't worry about the reliability. You make sure that that line is out if it goes down. It's taken a hit. So next slide, please. So managing reliability, immediate response, and we do daily reviews. Every outage is reviewed. weekly and monthly reviews, and annual reviews from our reliability team side of the house. So next slide. And just a little bit about how the power grid works. The restoration switching, there's a substation. There's two substations on the left. You can think of the high one and the low one. The high one has a failure. That subdivision, that set of many houses, can be moved from one circuit to another based on switches that are in the field. So that's often how we restore in an outage, is to move sets of customers based on the switches that exist in the field. And if we can install new ones to help that process, we'll do so. So that's it. That's my last slide. Thank you.